I have been a cardiologist for 15 years. In that time, I have witnessed a revolution in patient care, with patients living longer and having a much wider variety of diagnostic tests to choose from. The Affordable Care Act has opened the door to more and earlier testing for millions of patients, potentially saving countless lives. But aside from the copay, these tests have another kind of cost. Sometimes a patient must be repeatedly scanned to effectively guide their treatment. But as the number of scans increase, the cumulative radiation risk to the patient becomes something we cannot ignore. Until now, the only way to image the heart was to label the whole system. But what if we could use an agent that targets just the heart while sparing other organs? As part of my PhD, I identified a peptide that targets the heart specifically and efficiently. We have already patented this technology, which I call cardiac targeting peptide, or CTP. If CTP can carry a radioisotope like it does a fluorescent probe, I believe it could potentially reduce a patient's radiation exposure by as much as 90%. Our studies have already shown that CTP specifically enters isolated cardiomyocytes far more than any other cell type. It can target heart muscle in mice as well as explanted human heart tissue. I believe the time has come to use CTP conjugated with paramagnetic nanoparticles to study its mode of uptake using MRI, and CTP labeled with radioisotopes to determine categorically whether we can reduce systemic radiation exposure, at the same time generating better quality scans by decreasing non-specific background uptake. And this application would only be the beginning of cardiac-focused diagnostic and therapeutic applications.